Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will close our exercise of compositional oil modeling with PVTP software. And after completing all the process, now we arrive at the point where we will export the fluid model so that it can be used in other software, in other analysis, like maybe in MBAL software for material balance, or maybe in 3D dynamic simulation software, or like to Prosper for well modeling. So basically, we prepare the fluid model here, and then it can be used in other analysis. All right. So the final thing to do is to export the fluid model, the equation of state, so that it can be used in an integrated model. To do this, you can follow me. So first, double click on add report, on add export here. So you can click on this PVT sample or final fluid. Yeah. So it will be added onto this final fluid. Double click on that. So we have our EOS export here. Maybe I can move it. All right. Okay, so you can see in characterization window, we have our EOS export here. And then, so you can see our EOS export. This will place a new EOS export object on the characterization window connected to the last regression or the last fluid model, which is final fluid. You can also connect it directly to viscosity regression object here. Okay, and then double click on the EOS export. Interesting, very interesting window. So you can see our fluid model prepared in this PVTP can be used for IPM EOS composition or Prosper hydrate or PTEX black oil table or in EMBAL, right? It's like this. We can also use it in Eclipse black oil format, or Eclipse compositional format. We can also use it in CMG. Very interesting. CMG compositional, I mean, and then shell multisim or shell multisim compositional. We can also use it for VIP or Cheers, Kappa, Olga, and Roxar PVT format. So it is very, very, very robust. It is very, very useful. What happens here in PVTP, all the characterization process can be done, and then the fluid produced or generated here can be used in other software for reservoir simulation, for material balance computation, for well modeling. Okay, so after you select the export type, let's say MBAL with PVTP or MBAL PVT with depth, for example, or MBAL variable bubble point, you can then browse here and map to the location where the equation of state is to be saved, giving it an appropriate name, of course. Once ready, you can press export button here at the bottom of the window to create the selected format. So let's say I want to make for Eclipse black oil format, and then I'm going to browse, and then I will pause a little bit, and later on after the file is produced, I'm going to show you what happens inside the file. Okay, so I'm going to pause my video. But before that, let's see here. For phase table types, oil with dissolved gas, and then wet gas with vaporized oil, no water, let's say. And then we are going to use field unit. And then for the creation of fluid at higher saturation pressure, we are going to use fluid from near PSAT. We take this extend new fluids to maximum and do all possible undersaturated values. the keywords in Eclipse, we will use PVCO plus Pmax and PVTG. Okay, but you can also change it to constant oil with dry gas. That's why you will have keywords PVDG, DG for dry gas, and then RV constant, okay, or undersaturated oil with constant dissolved gas, something like this. Okay, so if you are familiar with Eclipse, you will understand what happens, what those keywords are. Okay, so let's set up this, this setting, and then I'm going to browse and map the file, the location for the file will be saved into, and I'm going to produce the file and show it to you later, what the files look like. Okay. Hi, folks. Actually, I've tried to make an Eclipse black oil format, but you see, you need to add more settings, and it's not that straightforward actually. So instead of making Eclipse format, I prefer for now, for simplicity, okay, it will help us a lot, the simplicity. Let's just produce the IPM EOS composition. So it's very, very straightforward. So I'm going to browse and find the location to which I will save my file into. And then after the file is reproduced, is generated, I'm going to show the PVTP file, the fluid model file with all of us. Okay, so I'm going to pause it again and see you after I open the file. Okay, now the file is generated and then I open it using Notepad. So we can see what's inside. You see here, so it's like this. And then binary interaction coefficients, only first half of array is exported. So this is our file for IPM EOS composition. Of course, you can produce the file in other format, but I don't think I'm going to do that here. Just for simplicity, I show you here the produced file for IPM EOS composition. Okay, so I think we can call it a day. We can close the entire series for compositional oil modeling. So it's a very, very interesting and enriching journey for us to learn the characterization in PVTP. And hopefully we can continue this learning with condensate modeling, compositional condensate modeling, still using PVTP. And until then, stay healthy and thank you so much. See you again.